Hello, my name is Sarah Churchill. I'm going to be showing you my final project, the Reinforcement Learning Room Explorer, and that is an expansion on Lab 9 that we did this semester. Um, so for the code, the only changes I made are adding a set called Discovered Walls, and that's where we'll add the coordinates of the wall boundaries that we found. And we implement that in the get next move section, where if a wall is bumped into, it'll get the reward -1, and then we'll add the coordinate that it bumped into, that is the wall, to the discovered walls set. And so for the code, we kept the room function the same. The room explorer, we just made the addition of adding that discovered walls set. And then the the explore room function, we kept the same as well. And then the get next move, that's where we added the self-discovered walls. We add the coordinates of the walls that are bumped into. And then that rest of that function remains the same, but you can see for each go left, if we bump into a wall, we'll add that coordinate to the discovered wall set. And that goes for the go right function as well, and the go down. All right. And then for our main code, we are counting the number of times it takes to reach the optimal path. And we're generating a random size room dimension. We're keeping it between 5 by 5 and 7 by 7 for this video, just so it doesn't take too long to run the code and find an optimal path. And then here's where we count how many times it takes to find a path. We run the room function, we find the dimensions of the room, and then we do the room explorer function as well. And then once the total reward equals the dimensions 5 by 5, 25, then we'll end the code and print out the optimal path. So we'll run the code right now. You see that one was really fast. It performed only 8 explorations, and that's because it was a small room, 5 by 5, and so the total reward is 25. And you can see it starts in 0, 0, and then it goes up, and then over, and then down, over, up, over, down, over, up, over, and over, and then it ends right there. And so it didn't revisit any of the same cells, and we found many wall coordinates. A total of 8 wall coordinates were discovered in this run to find the optimal solution. And yeah, that is my final project. Thank you.